Okay, welcome everyone. We are in week 7. So this week we are going through the module 4, chapter 4. Let me just hide this one. Okay, nice. So today we are going to learn about the conceptual database design. The very first example we had in our class was related to the book and was related to the author. And we talked about the kinds of relationship between these two. We learned about the attributes for each of these entity. We call them as an entity, and we mentioned that if you already have been through the system assistant design class, you already probably know about the ERD. So we mentioned that there is a relationship between this entity. So in general, we call these as an ERD or entity relationship diagram. So today we are almost gonna learn how we can draw this diagram, but based on the object-oriented modeling. We will talk about it in detail, so just don't get confused right now by the object-oriented modeling. The thing is, through this slide, this PowerPoint, in some of them, you will see there is a OO in top of them, which we call it object-oriented modeling, some of them ERD, entity relationship diagram, okay? But for our class, I will explain later, we are gonna always go with the object-oriented modeling. We will see, okay? At this point, these are just names. But the point is, why this conceptual design matter for us? Give me what's your thought? This diagram, what they are important for us? What do they give us? What do you think? Why they are matter for us? Instead of, for example, directly go to the SQL and try to create a database based on the SQL, why we always emphasize, hey, we have to first have this graph, this diagram, and then go through the SQL. Why do you think this is matter for us? Bless you. It's so effective and also efficient for us. So the main point is technically having this diagram, just with one look, we can have a better understanding of the whole system. Okay, so it has been proven that if you don't have this type of diagram, and if you go directly to develop a database by the SQL coding, the result that you usually will receive, they are not that much good. So the reason you need to always have the diagram, if you have the diagram, you can have details, you can have exactly the right attribute for it. You can have exactly the right relationship. We will learn today about the cardinalities, what type of relationship these entities they have together, unary, binary, we will see, or one-to-one relationship, many-to-many, one-to-many. That's the type of things that you can just only have by this type of diagram. So technically, this type of diagram, it's gonna exactly show us what's happening in the real world, in the organization. So again, if you had the chance to go through the system assessment design class, there are a lot of techniques that people would use to go through the organization to find, as I mentioned before, how the data would go through the different departments in the businesses. So that's why they call it as a DFD, data flow diagram. If you haven't had it so far, you will have it later. And then based on that diagram, you will have a chance to create the entity relationship diagram or the class diagram based on the object-oriented method that we will talk today. So technically, by again having this type of graph, this type of diagram, you will have a better understanding what's happening. As we mentioned before, it is always important to exactly capture the needed data based on the context that you are working. The famous example we had, I talked about your blood, for example, sugar or blood type. I mentioned that if you, for example, deal with some medical system, the blood type matters. But in the academic system, your blood type doesn't matter for the type of class that you would take. So that's also information, but information over there based on that context is needed. But here it's extra information. That's why we always have to make sure the type of data that we are collecting, it should be exactly relevant and enough, not extra, not less than enough. It should be exactly the optimized version. That's why this type of graph, people might go back after a couple of, I don't know, month, year, and try to revisit it in order to make it more efficient. Why make it more efficient? Again, imagine you have a database that you already created based on your diagram. In the diagram, you have 10 tables, 20 tables, whatever. Okay? In each table, you have couple of rows or uh, couple of columns, a couple of attributes. So imagine, for example, some of those attributes are not, I would say, that much necessary for your data sets. You might want to get rid of those. So in that case, you would definitely save time for your data people that they are entering data. You might save storage in your database because technically you are just avoiding to entering very unnecessary data. So that's why always this conceptual design matters because exactly address to us what type of information, how much information we exactly need to have. Okay, that's why this is matter for us. So today we will learn how we can exactly draw this diagram. There are multiple ways for it. One of them is entity relationship diagram. Okay, for this class, we don't go with the entity relationship diagram. We go with the class diagram. We name it class diagram. We will see again. At this point, don't get confused. These are just names. When you see the example, you will definitely understand. We would go with the UML design, which is based on the object-oriented modeling. So any of you, have you ever heard about the object-oriented modeling? Do you have any idea what is it? What is related? So object-oriented modeling, technically, it's a one programming techniques. The good news, in this class, we are not going to learn object-oriented techniques because it's a very, very broad concept. So in general, just give you one sentence of explanation what is object-oriented. They're gonna consider this one as an object and do whatever programming around this object. Fun example, you are playing PlayStation, you are playing some, I don't know, soccer game. So technically that player in the field is the object and programmer, they will go and do whatever they want around that object. This player should pass, this player should shoot, I don't know, this player should, I don't know, sprint to that way. So technically they are create everything around it. That's a very, very deep concept, very broad concept. Just understand it. That's the only meaning. Couple of programming languages, they use the object-oriented modeling, like Python, like C++. Those things that they are technically created based on object-oriented. So for us, we are using the class diagram, which is based on the unified modeling language in order to draw those diagrams, okay? When you see the example in the next couple of slides, you will see they are almost the same, except some notations are different, okay? So that's the difference. We will see in the example. That's why in the following slides, I put ERD for you, and also I put object-oriented modeling in order to for you to just understand what are the difference between those. So when you learn UML, it is super easy to also have the ERD the same. Even you have the ERD, it is super easy for you to have the UML. But the reason I am going with the UML notation because it's more common these days, especially if you have some like a application development class, which we have it in IS program. Dr. Thomas, for example, teaching that course. So they use this object-oriented modeling. Okay, that's why UML is better to learn. So technically, object-oriented, it's the concept in general. The language for it is the UML. Again, so technically, this is the hierarchy. So object-oriented is the main concept. The language is UML. And the type of diagram that we are using, class diagram, is part of this UML. So technically, today, we are learning the class diagram, which is equal to the ERD, entity relationship diagram, but with different notation. So when I go through the example, you will see what are the differences. So again, regardless of the UML, regardless of the class diagram or ERD, some of the concepts are the same, okay? So in each diagram, whatever diagram, always in order to understand better and definitely remember better, always have this book author example in your mind. Okay, this diagram, this simple diagram that we had in the very first day of class. So technically, book author, we call this as a thing, as an entity. The same for the book, the same for the author. So technically, in this graph, we have two things. We have two entities. And since we have the relationship between these two, we said this is the entity relationship diagram. Okay? So we call this one as an entity. In object-oriented modeling, we call it as an object. So far, the first difference. In an entity relationship diagram, we call it as an entity. Over there, we call it as an object. Different notation, different words. Relationship, exactly the name is the same between these two. So relationship association, there is exactly the same. Okay. So couple of examples for the entity or objects that we have. I don't know. For example, like a tangible thing such as vehicle, person, document. They could be. Imagine we have a table for the what's the spelling for the vehicle. Okay. In the entity relationship diagram, we call this as a entity. In the new one, in the object-oriented modeling, we call it as a object. Give me some attributes for it, for the vehicle. Just some attributes. Color, then
Type, I guess.
type, SUV, sedan, whatever. They made I don't know, the type of, is it hybrid, gas, whatever. So that's a bit of attributes for it. So technically, so far, everything is the same. Only over there, we call it as an entity. Here, we call it as an object. So before going to the object-oriented, in an ERD, in entity relationship diagram, we had it. This one has an entity, vehicle is an entity, and also each of the rows, which is each of the data. For example, the first one, I don't know, Toyota, the model 2025, hybrid, blah, blah, blah. So that one is considered as an entity instance, is a one rows of the data, okay? The attribute, exactly the same. The attribute here is the name, is the type, is the color, whatever. And the relationship, again, is the connection between the entities. And we name that graph as an entity relationship diagram, a diagram that shows us the entity sets and all the relationship between them. Nothing new. So far, ERDs. But for the OO, for the object-oriented modeling, which is, again, always remember this one. The language for it is the UML, and the diagram name is class. Okay. So here for the vehicle, over there we call as entity. Here we call it as a class or as an object. Okay, the same meaning. And also again, that Toyota which is made in 2025, whatever. That one again is considered one of the object instance or the class instance. Attributes, the name is the same. So again, in the object-oriented modeling, the make, the type, the color, we still call them as a attribute. Relationship is relationship. The diagram name is class diagram. Okay, so the diagram name is class diagram. So if we wanna write these two, so for the object-oriented modeling, the ERD, the entities type here, we call it as a class or object. Here we call it as a entity. The attributes, both of them is attributes. Nothing changed. Relationship is exactly, we call it relationship. Here, we call it class diagram. Here, we call it entity relationship diagram. Okay? So far, very similar, just different notation. Okay? So let's go for the, again, another type of notation. So for the ERD, this is the way that we show. So we have the entity name here is person. The attributes are first name, last name, birthday, gender. And then we just have what, like a vertical line that we can show the primary key here, for example, whatever primary key we have in this specific example. The way that we show it in the object-oriented, exactly the same. We just don't have this vertical line. Okay, so they are exactly the same. That's the way that we present. Regarding the naming of this one, so just have these two in your mind and it's gonna be easy. So the way that we name the entities, the way that we name the class, the object, okay? The customer, that we have two types of name. These are just for you to just just at least one hear it. I mean, it doesn't have any big deal for you. Just know it. We have two types of class name that we can name it. All we are learning right now how we can draw a diagram. In order to draw a diagram, we have to name this class. We have to name these tables. So when you want to name it, we have two types of name: lexical name, abstract name. Lexical, simple rule. Whatever you can write it, it's gonna be lexical. Social security number, you can write it. It's gonna be lexical. Phone number, you can write it. It's gonna be lexical. If you cannot write it, it's gonna be abstract. Okay, just the name, nothing very complicated. For example, person, you cannot write person. Car, you cannot write car. I mean the physical shape, considered in that way. So technically, that's a type of things. And also, it's always good whenever we have abstracts, like a person, like a vehicle, like a, I don't know, the example, faculty, like the students. It's always, we should have the identifier for it. Identifier could be considered as a primary key for it, okay? A student ID. Vehicle identification number, I think VIN number for the car, for example. Or, I don't know, the faculty ID, employee ID, okay? And we learned it for this one of the easiest way is to have this surrogate key. Do you remember the surrogate key? We talked 2 weeks ago about that. So we said we have primary key, we have foreign key, and we said, okay, we can have some specific key, surrogate key, which exactly the one could be as a, like an identifier for the text. Okay, so that's a so far the things that we discussed before. The same for the ERD, exactly the same. So over there we call it as a lexical class, abstract class. We call it here as a lexical set, entity set, or lexical entity, or abstract set, abstract entity. So that's the same thing. But one thing is so important when you are drawing a diagram. I forgot to mention. Chapter 4, there is only one assignment for it, which the assignment you need to draw a diagram. And the diagram is the one that I'm gonna grade it manually for it's not through the system. So we will learn next week, next Wednesday. We'll go through some example and I will show you some tools that you can draw a diagram. Okay. So we will talk about it. But just before we, I mean, without reading the table, the screen. So what these graphs tell you, the person, man, the person, man, what they are telling to you. What do you think about it? Technically, we have two right now, two entities, two class, two tables. Let's always make it simple as a table. One table is the person, one table is the man. Okay. What type of relationship you will see between these two tables? Just say whatever comes to your mind. Technically, you shouldn't know it. Just wanted to know what do you think about it. Sorry? Is the person, is the male? But what type of relationship they have? They both people. So close. They both people. So we can say they are kinds of a subgroup of something.
Humans.
Human. Okay? So the point is here, as we see, we can see that, can I say that the man in this specific example it's like it is a subset of the higher group. It's a subset of the super group. So here, for example, person as a one general entity, okay, it could be man, it could be women, it could be other type of gender, right? So technically it could be anything. So right now, this man, we can say that it's like a subset of that person group. Okay? Do you agree with this all? Makes sense? There are two terms for it, a little fancy but simple. Generalization group and specialization group. The generalization group goes with the person, the gen group. A specialization group goes with the man in this specific example. So technically, a specialization group, it's the subset of the generalization group. We will see this one a lot in a different type of diagrams. Why? For example, in your chapter 4 assignment, you have to draw a diagram for the business which is related to the therapy for people. Okay. So over there, we have to have some people group, and here one of them is employee, one of them is client, one of them is the counselor, for example. So technically, you're having one generalization group as a people and different specialization group. We will learn there is a always connection between these two. For example, whatever connection, whatever relationship this one has, this one also inherited. We will talk. Whatever attribute this one has, this one also inherits those attributes. For a person, person has name, person has last name, person has ID. So technically, man also has name, last name. So they are related to each other. Never mind about specialization and generalization. Technically, one of them is the subset, one of them is superset. One of them is the subset of the bigger one. So that's a type of different type of relationship. And the way that we show it is always goes from the specialization with a line and the triangle, and then you put the generalization. So is it clear what does it mean by generalization and specialization group right now? If it's not, let me know. If you need me to explain again, I will more than happy to do it. All good? So when we go through the example, it makes more sense to you. So technically, again, they are exactly the same. For the object-oriented, we call it a specialization class, generalization class. Over there, we call it a specialization entity, generalization entity. That's just different words, different vocabulary for presenting these two. And again, just this slide, this PowerPoint, I'm going to have the ERD. From after this slide, we always will go just with the OO object-oriented modeling. But for that type of generalization, a specialization, there are 4 new concepts that we need to learn. But before going through these complete, incomplete, disjoint, overlapping, okay? Regarding the person, man, woman, we are just discussing biologically in this case, okay? With all respect to all type of gender. We are discussing biologically. So person, man, woman, person, student, employee. What gives you the information of these two? What do you get from these two graphs?
Essential for each part A.
So technically, at least person could be fit in one of these two. Okay. What about the person, student, employee? And also some extra, no, just for that graph, just that graph. It could be also extra. A person could be a student, could be an employee, could be a person that doesn't work, doesn't study. Okay, and then could be athlete, whatever, whatever. Okay, so technically, the things that I'm gonna show you, again here, biology, we would say person as a generalization group, as a super group. At the end of the day, could be one of these two categories, should be one of these two categories. Okay, we name this one as the complete relationship. Here, a person can be student, can be employee, can be anything else. Okay, so in that case, we say, okay, in this graph, we have the incomplete relationship. So we learned complete, which means, let's read it from the text. Every instance of the superclass person belongs to at least one of the subclasses. Okay, so which means whoever is part of this group at least is one of these group, is part of one of these two group. Okay, but not every instances of the superclass belong to a subclass. So for example, here again, it could be somewhere some people that they're not a student, they are not the employee, but it still could be part of the person as well. So that's what we call it as a complete, incomplete. Okay. Now, disjoint and overlapping. again, biologically, in this example, a person can be man or can be women in this specific example. But here, a person can be a student. At the same time, they can also be students as well. So over there is an overlap relationship between these two. Here, there is a disjoint relationship between these two. Okay? That's what we need to know about the complete, incomplete. Again, when you're drawing a diagram, you need to know about these four concepts. What is the complete relationship? What is the incomplete? What is the disjoint? What is the overlapping? So if I want to ask you, one of you, now explain the complete and incomplete, who is going to do it to me? Just based on these two examples. Come on. Let's do it. The complete relationship, incomplete. You tell me. When we have the supergroup, whatever it is, the supergroup is A, the subset group is X and Y. When we have the complete relationship, what does it mean? Good.
Two, that like those two things can be true at once.
So X and just give me this example, X and Y. So technically, whatever people we have here, X and Y, they are could be just in the supercase. So there is no Z group here that we can say is also part of the A. So this is the complete one, okay? But there is a Z group that we can consider it as a also part of the supergroup. Like in that example, a student, employee, I don't know, athlete, for example. Okay? So if there is a Z group, we would say there is an incomplete relationship. If there is no Z group, it's all about X and Y, that's the complete relationship. Now, in our example, if a person, if a whatever could be X and Y at the same time, which means there is an overlap between these two. If it should be just X or Y, it would be a disjoint relationship. Okay? This one is so important. That's why I'm just emphasizing on it. One more time. We have supergroup A. Okay? We have subset group X, Y. If there is a Z group here that we can consider as A, that would be incomplete. If there is no Z group, it's all about the X and Y, that's a complete. If the outcome would be X and could possible to have the X and Y together, that's an overlap. If should be just X and Y, I mean X or Y, so that would be considered as a disjoint. Okay, so just that's the whole explanation of the different type of specialization and generalization. Again, generalization is the supergroup, specialization is a subgroup. All clear? Yes.
So no matter what, if you have more than two, subsets, it's gonna be complete.
If you can justify there is an, these two is an example. It could be 4, it could be 10, whatever. If you can find anything extra, so that means there is an incomplete. But if they are all, for example, in the academic system, imagine we are in the academic system. Okay, so people in academia, some people are students, some people are faculty, some people are staff. there is a very big importance that you need to understand. Depends on the organization that you are working, depends on the concept, it could be different. Okay, so depends on the concept. In this academic system, okay, we would say, okay, people in this system, they would be considered as a student, faculty, staff. There is no more group. So it means right now we have complete. There is no Z group here that we can mention it. But there is a possibility that the students are also a staff as well. So technically, this specific example, we have complete and overload. That's a relationship in this example.
So as long as it's distinct and justified, it's complete.
Exactly. If it's distinct and there is nothing else that we can add it. Again, depends on that specific organization. So that's how you need to write it in your diagram. There is a complete relationship, there is a disjoint, overlap, or incomplete. But let's learn about the relationship. The famous example we had is, what's the first example we have always between the entities? Book and author. Okay. There is a relationship between book and author, right? We have just two entities. We have just two classes. We have just two tables. Doesn't matter the vocabulary. So technically, there is a binary relationship between these two. That's what we call as a binary. So technically, it's a between two classes, between two tables, between two entities. If between multiple classes, it's gonna be an area relationship or whatever type of, we call it as an orbital relationship. Between three classes, four classes we will learn. Okay. So that's the thing. But what is unary relationship? Can you give me some example that the class itself, that entity itself, that table itself has a relationship with itself? So there is a like a relationship with itself. Do you have any example in your mind? Social security, how? How? I will give you the example. Try to justify it. Employee table. How the employee table has a relationship with itself. Please. Exactly. Exactly. I here as a faculty working in this table as an employee, right? My department chair, Dr. Humayun Zafar, he is also employee, but he is a supervisor in this section. Dean Robin Shirami for the business school, she is also employee, but my boss Humayun report to her his boss, which is Robin Shirami. So technically, there is a relationship with itself. Employee report to employee in this specific example. That's what we call it as a unary relationship. I am reporting to an employee to advise to the supervisor, which that supervisor also considered as an employee. But again, organization by organization, it could be different. For example, in some organization, they could have some specific table just for the supervisor, some specific table for the C-suites. So technically, table would report to each other. but it doesn't matter to us. At this point, we just want to understand what is the unary relationship. So technically links between the each instances, between the each record. Okay, that's what we call it as a unary relationship. Oh my God. So the simple example, a student's course. A students are a table, are an entity, are a set, are an object. So they're all the same. Courses again, that's a table, that's a set, that's an object, whatever we call it. So a student took courses. That's a type of relationship that that. For example, Adam took physics 201, 211. So that's a type of the way that we need to address it. So we can see here that we have like a verb between these two tables. When we are drawing this diagram, we have to mention what type of verb could describe this relationship. Or the same here, supervisor, class, which for example, Paolo and Craig, and the worker are Kent, Bruce, and the rest. So technically, supervisor supervises worker. Right now, Paolo, for example, supervises Kent and Bruce. Okay, so that's the way that we need to address. So right now, this specific relationship, can you just explain why there is a complete and disjoint between these two? Just explain it why this is a complete relationship. At the same time, this is a disjoint relationship. Go ahead. Any other table? Okay. Okay. So technically, in this example, in this organization, employee is supervisor or worker. We don't have any other Z group. So that's why there is a complete relationship. And at the same time, there is no possibility in this organization that you be a supervisor while you are also a worker. Okay, so that's why there is a disjoint relationship. There is no overlap between the supervisor and the worker group. Okay, so again, that's the way, for example, we can write it, but there is one important thing to understand. Let me go through this example. As students, how many courses one student can take? Many. Courses can be taken by how many students? Many. So technically, there is a many-to-many relationship here. There is a one simple, clear, and very strict deal. We shouldn't have many-to-many relationship in diagram. They call it as a cardinal sin. So cardinal, if we talk about the cardinality right now, cardinal sin. When we have many-to-many relationship, we should break it down to the another table, another set. Okay? In that case, we are technically, let's say this is many-to-many. We are changing it to one new one. So it's going to be one-to-many, one-to-many. Okay? In this specific example, as students can take many courses, courses can be taken by many students. A student A, the course name IS 3280, a student B, IS 3280. We are creating a new table, which here we are naming it as an enrollment. It could be whatever you would like, but it should make sense. You cannot, for example, name, I don't know, whatever that doesn't make sense. No example right now in my mind. So technically, this new table, these are the new entities, these are the new data sets for that specific table enrollment. We call this table, this class, this set, this entity, we call it association class. Okay, so right now that's the table that we call it as association. So technically association class is a real class with the characteristic of any other classes, including attributes and other relationship. Okay, so that's what we call as an association class. But let's now talk about the cardinality. We already talked about it, nothing new. Okay, this is a specific example. Try to read it for me. A person has social security number. Okay, can we say that each person has only one social security number? Legally, each person should have one, am I right? So we are putting one here. It goes from left to right. Each person has only one social security number. If I want to read it from the right to left, so social security number can be assigned to one person. Okay, so this one is for this way, this one is for this way. So technically, we can say each person has only one social security number, and each social security number belongs to only one person. So in this specific example, we can say there is a one-to-one relationship between these two entities. Okay, let's go to the second example. So now you can just understand it right now. Just stay for a couple of seconds. The way that we are showing it in the UML, in the class diagram, and the way that we are going to show in the ERD. But again, for our course, we always stay with the object-oriented model. The difference, hello. So the difference, we are using the cruise, they use the cruise foot notation. So whenever there is a zero relationship in the object-oriented, in the ERD, here both we have zero. Okay, the point is here we write it zero above the line. Over there they are writing this way. When we have one, this is the way that we show it on the object-oriented modeling. In the ERD, we're showing this way. And when we have many in the object-oriented modeling, we have asterisks. In the last slide, all of them are there. Just don't worry. Over there, we show like a foot crew. So that's the way that they show it as a main. Okay. So right now, in this specific example, we can see person has only one social security number, and social security number can be assigned to just one person. Over there, we had one. Here, we are just crossing a line to the relationship. So now it makes more sense to you the difference between these two notation. Again, they are exactly the same, just a different notation. The way they show it in a different way. The point is, these cardinalities, 0 to 1, 1 to 1, 1 to many, there is a minimum and maximum level of cardinalities. How? This example. Let me just show you this example. Oops. So, technically, a person can have no social security number, and also maximum can have only one social security number. Do you agree all? So that's why we name it, we should have it like this. We should show the minimum and show the maximum. In this specific example, a person can have 0 social security number or maximum 1. A social security number can be assigned to no person or maximum 1%. So the same cardinality, but we should show the minimum and maximum level of cardinality in the diagram that we are creating. So another example. Same for the ERD. Over there, we have 0, 1. Here we are, over there we show 0, 1 like this in the object-oriented. In the ERD, we show this one. Again, for our course, for the assignment for chapter 4, you need to go with the OO, with the object-oriented modeling techniques. But here we are just showing you that the ERD is almost the same, just a different notation. Okay? This is a specific example. Read it for me with this current knowledge that you have. Someone loud, clear, read it for me.
Only one supervisor,
One more time.
it's, only one supervisor.
So no, read it that way. The minimum, address the minimum and maximum for me. From left, right.
Minimum supervisor can have a infinite dependent.
So almost correct. Supervisor can supervise at least one or many worker. They are supervised by one and only one supervisor. Again, this is in this organization. Maybe in some organization, there is a different rule that one people can be supervised with two people. For example, there are two co-supervised in some section. But in this specific example, this is the way that we read it. One more time. Supervisor can supervise at least one worker or many workers can be supervised by one and only one. That's the way we read it. We say one and only one. We don't say minimum one and maximum one. One and only one. Okay? That's the relationship between these two groups. Same here for the ERD. For the one aspect, which is one to many. Okay? So here we will say line and then this cruise foot like this. And one is just two line across them. So again, we are not going to work with the ERDs. So we are going to work with the OO. But right now, I'm just showing you what's the difference. Yes.
What if you wanted to have like distinction? So you have one on that side, right?
Yes.
So then you wanted to have one.
5 is many.
So-
Yeah. Consider as a many.
So if you're looking at that, how would you distinguish between being one and many versus one?
Technically, whatever above one, we consider as a many. For example, you as a student, you can take 4 courses per semester.
So the person looking at it wouldn't understand the parameters.
No, it just consider as a many. Many could be anything. It could be over 1. Okay, so it could be over 1. Whatever above 1, we consider as a many. There is like a extra documentation you can put into the database. We will talk about it later in chapter 7 or 8, I think. Like a extra dictionary for your database. People add more details, whatever extra details that they want to add it. So you can add it over there. For example, in this organization, we have a rule that each supervisor can maximum supervise 5 workers. So that's an extra dictionary that you can add it. Okay. So technically now makes sense for you. The relationship between the generalization and the specialization. So technically, a man is going to be a one and only one person, okay? But a person can be 0 man or maximum 1 man. It could be female, it could be whatever. So that's the type of relationship we have here. So technically in the specialization side, to the generalization, we always have one and only one. But from the generalization to a specialization, we have the maximum one and minimum and maximum one. Minimum 0 and maximum 1, yeah. So the same for the ERD. So that's the whatever notation we learn. Here, a one-to-one relationship. Each person has a 0 or 1 social security number. Each social security number is for exactly 1 person. So the same between the supervisor and worker and the student. Here, that's the issue that we said. Students can take many courses. Each student took 0 or more courses. There is a many-to-many relationship. Many-to-many relationship, we call it as a cardinal sin. So we have to always break it down into the association. Okay? So the same, I put the object-oriented as well, the ERD as well. So you can just easily, by comparing these two slides, you can just see the difference between these two. So now we know object-oriented, ERD doesn't matter. They are 99% the same. Just the way that we show for the notation, that's a difference. 0, 1, many, the way that we show it in the ERD. Okay, so they're almost the same. But we go with the object-oriented modeling for the so for this attribute, we already talked, we have the foreign key, primary key. So without any doubt, all of you right now would know what is the foreign key. Without any doubt. So that's the type of thing. So there is a rule, inheritance rule. By inheritance rule, it means a specialization group, the subgroup, inherits all of the relationship that the supergroup has, the generalization group has, and also all of the attributes. Again, for the person group, for the man group, whatever attribute this one has, this one without any doubt have the same attributes. Okay, between the person and the man. So I think we have the example here. So that's again the name, the way that we name it. So right now, let me go through the. This is again the key attribute. Yeah, this example. The person have the social security number, name, address. Okay, so we would say also a married person. In this case, they also have the social security number, name, and address. But when you are showing it in a graph, in a diagram, you don't repeat those attributes for the subgroup again. Like this example, you don't write social security number, name, address, and then a spouse name. When we see this graph, we know that the married person, how many attributes married person have right now? How many you have? How many married person? Married person inherits all of the attributes from the generalization group as well. So how many? 4. It has social security number, it has name, it has address, plus it has a spouse name. But we don't repeat it again into the graph. Okay? But when we see this one, we will say, okay, married person, there is a generalization, a specialization relationship between these two. So which means married person has exactly the same attributes plus 1 extra. Okay? The same for the relationship. Whatever relationship, person, entity has in that organization, married person exactly have exactly the same. So right now, person and company, for example, I don't know, John Doe work with that XYZ company. That married person, which is again John Doe, exactly again work for that company. So that's the type of rule, inheritance rule, which means whatever attributes the supergroup have, the subgroup also has those attributes, but we don't write it again in our graph. Okay, so let us stop here. So next meeting, we are gonna work on more details, more example. Let me stop the recording. Okay, so welcome everyone to week 7. We are in section 2 for the week 7. So let's have a very quick review on the chapter 4, what we discussed in the previous session, and then we'll continue working on today's session. So we were talking how we can develop some conceptual data modeling, and we went through different type of techniques that we need to know in order to develop a conceptual model. So just again, some of you that were not in class on Monday, we mentioned that for developing those diagrams, we so far learned about the ERD, entity relationship diagrams. That famous example, the book, the author, each of them are the entities. So technically, we are creating some relationship between them, and the graph itself, the diagram, we call it entity relationship diagram. But the point is, from now on, we will work on the object-oriented modeling. Object-oriented modeling is a technique for programming. We don't want to we don't want to go with the object-oriented in details. All the things that we need to know from object-oriented modeling is the UML, Unified Modeling Language, which the result is going to be class diagram, which is equal to the entity relationship diagram. Equal, not, I mean, equal, it's comparable. So technically, the results are almost the same with a different notation. So we talked about the difference between these two. For example, in the ERD, to each table, we call it as a entity. You remember that? So the table in the ERD, we call it as an entity. Here in the class diagram, we call it class or object. The relationship between these two are relationship, it doesn't matter. Attributes, in both, we call it attributes. But the only difference is, again, the name of the graph in this one is a class diagram, in the other one is the entity relationship diagram. So in some study, you will see OO, which means object-oriented modeling, and some of them ERD. But for this course, from now on, we always go with the object-oriented modeling because it's more common, it's more broad, and it's more useful for you to learn the notation for that one. So technically, we just mentioned a little difference between the way that we show in the object-oriented modeling and also the ERD. So the difference between the entity, and then we talked about a little lexical class, abstract class. Not a big deal. Abstract class, as we mentioned, if something cannot be written, we call it as an abstract class, like a vehicle, like a person. But if something is returnable, we can return it, we can write it like a social security number. It's a lexical class. Again, not a big deal. Different type of key that we already know: primary key, foreign key, surrogate key, external key, all the things. And then we talked about the very important things: specialization, generalization. So some of you that were in the class on Monday, just if you want to explain to your friends what's the generalization and specialization, can you just give me a very quick note for this one? I know that you definitely know what does it mean by a specialization, generalization. So if someone just are volunteer, come on, you're all my loyal students that always attend class with no expectation of attending. Yes, go ahead. Okay, so good. So very short, but fully informative. So when we have the relationship between two entity, two class, two object, two class. So the higher group, we call it as a generalization or super group or super class. The lower level one, we call it a specialization or subclass. So technically, that specialization could be considered as a subset from the main group. In this case, if we have the person as a generalization group, man is a subset, female is a subset, other gender is a subset. So technically, that's a relationship between these two that we call it as a generalization and specialization. Okay, and then we talked about the multiple version of this specific relationship: complete, incomplete, overlapping, disjoint. Other, just explain what does it mean by complete, incomplete, and disjoint and overlapping. Maybe you should go just. You know it. You know it. Mm-hmm. Exactly. Mm-hmm. Exactly. So we were talking that, for example, if the higher level, the generalization is A, and there is a X and Y. If all the data, whatever we have, just could be categorized in X and Y, we can say that we have the complete one. But if there is another Z available, we will say this is incomplete. And if it is just X or Y, that would be a disjoint. If it could be a X and Y at the same time, that would be like an overlap. Again, just make sure to watch the videos when I'm gonna upload it tomorrow, probably, in order to understand better if you didn't attend the Monday class. And then we talk about different type of relationship: unary, binary, and multiple versions. So technically, if the entity, class, object has a relationship with itself, we call it as a unary. So as an example, what was the example in class? Which was the example? What was the example for having the relationship with itself? So the employee table, for example, the employee table, I am the employee at the school. My boss, the department chair, he is also employee, and also the dean is also employee. But each of us reporting to each other, but we are all part of the same entity, same class. So technically, we are reporting to each other, to itself. So employee report to itself. That's a unary relationship. If it's between two binary and more than two, definitely it's gonna be more than two version. And then we talk about the association class. We talk about a very big deal that if you have a many-to-many relationship between two classes, two sets, two entities, technically that's what we call as a cardinal sin. You have to definitely break it down to the association class. Okay, like here, a student can take many courses. Courses can be taken by many students. There is a many-to-many relationship, but the point is, as we mentioned, this is the many-to-many relationship. That's like a cardinal thing. That's why we need to make sure that we always have an association class in order to resolve this issue. So here the enrollment would be, for example, a student A took the course IS 3280, a student B took the course IS 3250, whatever. So those are the new instances for the new column, new objects. And then we talked about the cardinality. So many-to-many, one-to-many, zero, one-to-one. So here in the example, we said that, okay, a person can have at least 0 social security number or maximum 1, and also social security number can be assigned to maximum 1% or minimum 0%. And we said they should have the definitely minimum and maximum for it. And then the way that we are showing it, that's the difference between the object-oriented and the ERD. Again, make sure to go through the video and check all of these. And the maximum type of relationship that we can have all the notations for the object oriented and also for the ERD are here as well. And the last part of the class, we talked about the inheritance rule. So we mentioned that in a generalization and specialization group, so we technically, whatever attributes, whatever relationship the generalization group, the subgroup, the supergroup has, also the specialization also has the same one. So like here, for the married person, how many attributes we have for the married person? 4. So technically we have spouse name plus those 3. But for the person itself, how many we have? 3. Okay. So technically, in this generalization, specialization, whatever attributes the higher group have, the subclass, the specialization one also have the same as well, and also the same for the relationship as well. So now, today, we are going through the some example. So in the D12, you will see 2 PowerPoints. One with the OO, which is the object-oriented modeling. One is with the cruise footnote. So that one is with the ERD. So we just go with the object-oriented. But those files, they're exactly the same, just different notation. But again, as I mentioned, we completely always go with the OO. So just a very quick example to show you. So you can see right now, this is slide, the difference between this slide and this slide. So you can see it together. So they're almost the same, just technically this one, the notation is different with the ERD. So let's close this one. Just having the OO. Now for today, let's go through some example, because as I mentioned, chapter 4 assignments, you have to create some diagram, some class diagram. That's why it is important to understand how we need to deal with it. Okay, so technically, for drawing a model, you need to consider all the necessary aspects of that business, all the necessary entities, all the necessary classes, all the necessary attributes, everything, whatever you need to consider in order to have a better diagram. Because at the end of the day, as I mentioned on Monday, whenever you have the best version of your diagram, definitely the database that you are going to create out of that diagram, it's going to give you the best result. It's going to give you the best answer. So by end of today, you will see why this one matters. When you don't have a good diagram, technically you cannot expect to have a good result out of the questions that, for example, high level will have. So right now, today, we are going to learn to create some data model, but we will go step by step from the small part, and then we are going to extend it to maximum, have the whole system together. So let's see this specific example. We are creating some data model for a banking system. Okay, so for this one, based on whatever we have already learned, so we can see we have 3 entities here. So we have 3 class here, 3 tables here. So we all know entities, class, table, object, they are all the same. So one of them is customer, one of them is checking account, one of them is saving account. So technically we are saying that, okay, customer, they can have checking account and also they can have saving account. Okay, so technically out of these we can say, we can ask question by SQL, how many customer we have? Simple, select asterisk from the customer table, it's going to give us the information. You see, how many customer has the checking account? Select asterisk from customer table, join checking account table, on which one, for example, the customer ID for each. So you can set it. That's the type of question that we can ask. We are also reviewing the SQL coding as well. So for this example, based on the current knowledge we have, so read it for me from the graph. What does it mean by these cardinalities? Just read the graph for me based on the cardinality knowledge that you have. Unfortunately, you have to read it. Yes, go ahead. So customer can have minimum 0 checking account or maximum 1 checking account. And exactly, checking account could be assigned to one and only one. This is the one and only one customer. And the same for the saving account as well. So if you remember, I mentioned that depends on your business, depends on the context that you are working, these numbers could be different. So technically, we know that in a real world banking system, each customer, they can have multiple accounts. So in this example, we are just saying, okay, assume that they can have only 0 or maximum 1. But in the more realistic version, so customer, they can have 0 checking accounts or many checking accounts, and checking account could be assigned to one customer or many customer. You can just have a joint account with your partner, so technically you both have a one account, but technically account assigned to 2 persons. So that's why there is a many relationship here as well. And the same for the customer and saving account. Customer can have 0 saving account or saving account can be assigned to one and many customer. Okay, so that's the way that we are going forward for this one. So far we know that, okay, this is a customer entity, this is a checking account, saving account. We are developing the system for the bank. But the point is, we have multiple type of customer. And also we have multiple type of account as well. So again, for having more realistic example, we need to go through details for those as well, right? So right now in this one, again, based on your knowledge from the last session, go through this graph first for me. What does it mean by this graph? Customer. The main issue is you're shy, otherwise you know. Mm-hmm. Mm-hmm. Okay, exactly. Exactly. So right now, we know in the real world system, the customer could be categorized in these 2 versions. Just a real human or like a system, like an organization. So that account can be, that customer can be just a human customer, one customer, or multiple, that doesn't matter, or the organizational customer. So technically, based on our knowledge, we cannot consider any other type of customer, again, in this example. But generally, your customer is human or the organization. We don't have anything more. So technically, since there is no other, that's a complete relationship between these 2. And the point is, at the end of the day, customer is human or is organization. We cannot have a human organization customer. So that's why this is a disjoint relationship. The same for the account. Account could be checking, not same, sorry. Account could be checking, could be saving, could be loan account, could be whatever type of other accounts. So technically, we can consider some other account as well. That's why we are calling it as an incomplete. But the point is, account is checking or saving. We don't have checking saving account. That's why the relationship is disjoint, is not overlap. So right now, again, we added more details to the model that we are developing. So right now, we can say, okay, with that customer, with that account, with these 2 type of things, now we have more. The point is, we talk about the inheritance rule. By inheritance rule, which means whatever attributes the generalization group have, the specialization inherit those attributes as well. Whatever relationship the generalization group have, the specialization also have the same relationship. Here, the human customer. How many attributes human customer have? 4. First customer number, address, plus date of birth and mobile phone. So that's a 4 because it's inherit of these two as well. And the same for the rest. So technically that will be more detailed version again. So let's continue more. So right now, as I mentioned, inheritance is related to relationship as well. So customer can have 0 accounts or many accounts. Accounts can be assigned to at least one customer or many customer. That's the way that we are reading it. And again, we can exactly say that's the same relationship, for example, for human customer to the, for example, saving. Exactly inherit whatever the generalization, the super group have. So right now we can say, okay, this one could be like a example for the banking system, okay, with some level of details. But let's go through the so far the example that we had so far for the chapter 2 and 3, which was the Red Cat database for the shoes that we used to have for the chapter 2 and 3. So let's imagine we have these 4 tables. Sale table, we already have them. Customer, product, manufacturer. So we know that we can just read this one. Sale table, which means the primary key is sale ID, and these are the rest of the attributes. And foreign key is customer ID, foreign key is product ID. So technically, we can say, okay, if we are going to connect sale to the product table, that could be through the which attribute? Product ID. The same sale to the customer table, that could be also go through the customer ID. That's the node that will select asterisk from, I don't know, sale table, join customer table through the customer ID from customer table equal to customer ID from the sale table. The point is, when we are creating a conceptual model for this one, we usually remove the foreign key from the final model. Why? Because the relationship itself shows that type of foreign key relationship. You will see. So right now we know that the sale table, whatever it is, the customer table, just out of this foreign key, we can interpret that there is a relationship between these two tables, right? Is it okay? So technically that relationship is because of that foreign key. So just, I don't know, for whatever reason, it's not a rule, it's not a must, but it's better to just remove it. You don't put the customer ID here and customer ID here again in the graph, in the class diagram. So let's see. So right now, this is the one that we already have it. The sale table. So technically, those attributes except the customer ID and also product ID. So that's the way that we can connect these together. So sale includes some products. Let's read it together. So sales can have one and only one product. Product can be assigned to 0 sales or many sales. And now you might say this is not okay because a sale can have multiple products. You are right. But that this example, in this case, we are assuming that's just only assigned to one and only one product. Product made by manufacturer, right? So each product can be made by one and only one manufacturer, and manufacturer can create at least one or many products. And the same, sale can be assigned to one and only one customer, and customer can purchase 0 or maximum item. Okay? So we know that this graph is not complete what type of information you are missing in this table, in this graph, based on the database, red shoes database that we had, red cats database. So we know that, okay, products are made by manufacturer, but what about purchasing from manufacturer? So okay, they are creating it, but we, as a, for example, the seller, we have to purchase from them. So we need to have some purchase table for sure. It's missing. Or for example, in this company, employee works. So we should have the information for the employee as well. You see, that's a type of missing information. So that's the usually start. They usually come with some like a draft version, and then they go through the details of the organization. They go through the business, try to understand the business, ask question, hey, what type of employee you have, what type of customer you have, and then they would go and try to develop the model better and better. That's what we are doing right now. So technically, this model doesn't address the employee. It doesn't address the product purchase. So we are going to fix it. Okay, by fixing, which means we are going to add more elements, more entities, more sets, more objects, more table to the diagram. Okay, so employee table. We went to the HR system and we said, hey, we are developing a class diagram for your business. So we have some question regarding your employee system. How many type of employees you have? Okay, so we have two types of employees. We have wage employee, salary employee. Okay, what type of information you have from your employees? Okay, we have first name, last name, phone, hire date. And for the salary people, we have the salary for them. And for the wage employee, we have the wage and maximum hours that they are allowed to work. So again, simple, asking some question. Now I have more information to develop this model. So right now we have this one. Also, we would like to know about the cardinalities for this one. So this is the employee table. So technically, the supervisor are in this table, the regular worker are in this table, the CEO also are in this table. Everyone are in this table. So technically, there is a relationship with itself. We can have this one. We can say, okay, employee can manage 0 employee or max or many employees, and an employee can be managed by 0% or maximum 1%. But always it's more better, more beautiful to have this way. Because this way you are exactly creating one extra table, which is unnecessary. But this one technically is more efficient. So one question, let's go through the cardinality for this one. What this one's saying to us, employee can manage 0 employees or many employees. And also, sorry, employee can manage 0 employee or many employee, or employee can be managed by 0 employee or maximum 1. So who is that 0 in this business? The one that no one technically manage that person. The top guy, whoever it is, the business owner, the CEO, the whatever. So technically that guy is the top level. That's why no one picking him. So he is the one that everyone's report to him. Okay. So right now we have some more information for adding to the table. For the product, the type of product. So we know this product, it's a shoes company. So each product has sizes. What are the relationship between the product and the size? What is the cardinality between these? A product can have many sizes. The size can be assigned to many shoes. Technically, there is a, what is the relation between these two? Many to many. Many to many is a cardinal thing. So which means we have to have association class for it. The association class, we first show it with the like a dash line. That's the way that we show it. And then for this one, for example, choose A with size 7 is a one example for this one. Choose B with size 8 is the another one. So that's the way that we are, again, developing this specific model. And we can see also for the sale item. Right now, for example, shoe A with the size 7, shoe B with the size 8. Okay? Right now, this one should be sold to customer, some sale item. And also the same for the relationship between the sale and inventory. Each customer can purchase many inventory items. Right, they can purchase one of these, and the rest. And also, this specific item, shoe A, with the size 7, can be sold to many customers as well. So again, there is a many-to-many relationship. So again, another cardinal thing. We have to definitely go with the sale item table, whatever name. You can name it anything. We are naming it sale. Now this time, for example, shoe A with the size 7 goes to customer B, goes to customer C. So this one could be a new example for this table. So it might be confusing, but it is not. As long as you can see there is a many-to-many relationship, you have to always break it down with the association table to finally have the version that you can say, okay, right now, this sale is exactly assigned to one sale item or many. The same for the inventory as well. So, any questions so far? All good. Now, we also, as I mentioned, there is no purchase table in that specific model, the first model we have. So right now, we are also adding purchase to that table as well. So let's read the table from the left top to the right down corner. Okay? So right now, employees make purchase. Each employee can make 0 purchase or many purchase, but each purchase can be just made by one and only one employee. Okay? And then this purchase technically should be available based on the manufacturer. So each purchase, each item, they can made from 0 manufacturer or maximum 1 manufacturer. In this specific, sorry, one and only one manufacturer. And manufacturer, they can create 0 purchase, or because they might create something that no one purchases from them. That's why we have a 0 here as well. They might create something that no one is purchasing it. That's why that there is a 0. But they can sell it as many as possible. The same, the rest of the relationship, again, that purchase from the inventory item and the purchase item that we just created in the previous slide. And then maximum, we are having the product table and the size that, again, the combination is for related to an inventory item. So after all of these, this could be like a final model. And the thing is, this model is not, for example, guaranteed and fixed model forever. Because again, there are always trying to optimizing the system. Again, when you are creating a database, you are creating exactly based on each of these attributes. if there is one unnecessary attribute in this one, you are wasting time, you are wasting storage, I mean, in the cloud system. You are technically creating some reason to having error. So there could be a lot of consequence. So that's why it is always good to remodel, review this model and try to make it better, update it as much as possible. So right now, this one, if you want to understand that business, that a specific business, only you need to just first have a knowledge about this 101 all stuff, and then spend 5 minutes on this table, and you can just understand the business in that specific context. Here we can see, okay, there are customers in this business. This customer, they are creating some sale table, they are purchasing something. This sale, it comes from the production. Production table come from the manufacturer. Then they have to purchase items from the manufacturer in order to input those, for example, shoes into the business. Those shoes, again, they go to the inventory system. Those inventory systems are available to purchase. Who are doing all these purchases? Employees. Employees have this type of information. And again, as long as the business going bigger and bigger and bigger, you will have more tables. Now, just for a second, imagine a company like Amazon, like Apple, how this table could be crazy. How many vendors they have, how many type of different businesses they have, how many type of product are created. For Amazon, they have totally different system like AWS. So just imagine that one is different from just the regular, I don't know, items that they are selling in the Amazon website. You see that one, how this one could be crazy, it could be complicated. So we need to have these in order to develop the database. Next chapter, we will do reverse. We will have this, and then we will go to create some database. So that's why it is always important to understand this one. So for the chapter 4 assignment, you have to develop something like this. We will go through it next week. Let's have another example. University. In a university system, in an academic system, we have been assigned to create some conceptual data model for it. Okay, in the university, let's just imagine together what type of tables, what type of entity, what type of sets, what type of objects we have. Just name them some. Student, faculty, it could be staff. So that's the type of things that we can say we have. So for a student, for us, it matters which courses they are taking. In courses, again, it matters how many sections that courses have. Right now, we are IS 3280, we are in section 01. There is a section W01 as well, which is the online version. In each section, it matters for us which books people are using it. For the faculty, again, it is matter which faculty teach which courses. Again, for the courses, which section. Again, for the section, how many students enroll in that class. So you see, that's type of extra things that we need to always consider to have the best model. And who knows, maybe the best model have not come yet. So you have to work on and make it better and better and better. So right now, we have the students, we have the courses. As students can take how many courses? Many. We name greater than one, we name it many courses. Each courses can be taken by, there is a many to many, that's we call it as a cardinal. So which means we have to have association class or association table or association object or association entity, whatever. What we are naming here, we are naming it enrollment. You can name it whatever you want, but it should make sense. You cannot name it Apple. It should make sense, you see? So a student A take course IS 3280, one of the instances of this table. And for sure, students have grade as well. But the point is, in this specific example, we can see that the students again can have one courses or many courses. Courses can be assigned to 0 students or many students. This 0 is correct or is not correct? It's correct. There is a course that no one wants to take it. That's why they usually have some courses that they don't offer it anymore and they will terminate it. This grade for the enrollment. For example, Hossein Mohit, course IS 3280, he got A. Can we have this grade in the student table as well? No, because each grade is assigned to a specific course. So if you were to consider it here, that would be, for example, Hossein Mohit, grade A, but this A for which course it is? That's why we need to always also pay attention where we are putting the attributes. The attributes should be in the right table. If we put it in the wrong table, it's going to just create chaos and mess. So that's why that one is also mapped. So the same for the professor. Professor can teach many courses. Courses can be taught by many professors. So technically, there is a many to many. That's a cardinal sin. So which means we have to have the association class, association table, association object, association sets. We call it teaching announcement. You can call it, name it anything. Now, these people use different textbooks, so that's also could be also extra thing as well. So right now, we are trying to again developing a model to have a better model. So in this model, we can say the students, when they are taking courses, again, they have a chance to choose which section they would go. So technically, the students should take at least one sections or many sections, which is possible. Again, sections can be assigned to 0 student or many to many. We go with the, again, the association table. And the point is, this section itself, for example, section 01, which is assigned to IS 3280, we have also section W01. So each section can be assigned to exactly one and only one course. Section 01 is assigned to just this course. And each course can be assigned to 0 section or many sections as well. Okay, so the reason that we are learning it step by step, because technically you have to create it step by step as well. It is impossible to have the final version when you start the job, with just one time effort to, drawing the diagram. You have to always go step by step, try to extend it, expand the model. So same for the professor as well. Exactly, students can take many courses, sections. The same for this professor as well. So they are exactly like a mirror version. So exactly everything the same for the faculty as well. And the point is, in the academic system, we also have year, we also have semester. That's why we need to consider that one as well. So for this one, a season can be assigned to 1 year or many year, fall 24, fall 25. So, and also a year can be assigned to 0 season and many season. That zero season here to me doesn't make sense, but probably this is based on the like a more older system that they might have different type of semester, not the seasonal based, maybe quarter based, something like that. In my home country, when I was child, we didn't have 2 semesters per year. We had 3 semesters per year. Okay, so that it wasn't based on the season. Right now, they are exactly like here, the fall and spring, regardless of the summer for sure. And here again, so season can be assigned to 1 and many, year can be assigned to 0 or many. And since this is the again many to many, we need to have the association. The association is gonna be a term, a semester. Fall 25, beginning date August 25 to the December 25. Okay, so now with having all, now we can say this is going to be like a more comprehensive data model. Okay, so with this one, I can say probably I can answer any questions for this specific database with this model. I can say which students in which semester, in which year, took which courses, with which faculty, and what was the grade, and what was the book, and the same, which faculty has been already taught, how many courses, which sections, which courses, how many students they had. You see, that's the type of things that we are trying to answer. So this is the best way to just see this model. So right now we have 2 type of input for this. So technically, we can see here, we have the students, John Gary. One of them is for the winter 2009, and the other one is for fall 2008. Okay? So what term did John Gary take? Yes. Okay, so right now, what term did John Gary take Sociology 101? Answer the question. We can start together. What term did John Gary take Sociology 101? So we can see the Sociology 101 is offered here as a course. The name is John Gary. So technically, the only courses here is Sociology 101. So technically, that course took by Gary exactly in winter 2009 and fall 2008. So technically, the guy took it twice. Okay, because in that specific example, we have just 1 student and 1 exactly courses. So what grade did he get each time? In winter 2009, what was the grade? B minus, and for the fall 2008 is the D plus. And for each time, who was the professor? So Weber taught section 3 for the winter 2009, and Davis taught section 2 for fall 2008. And did he use the same textbook each time? No, they taught different tools, sociology fundamental and essential of sociology. So again, what we are learning all is for a reason, to first create some conceptual model. And by conceptual model, you will then be able to create a database. And when you have the database, you can do whatever you want. You see? Easy. That's easy that you can just sleep. So that's the point. But the point is, I'm gonna stop here because if I want to go through the chapter for assignment, it's gonna be a little longer. So for chapter 4 assignment, you have to create some graph like this. Okay, It's a for the like a system that's like a psychological system. So they have some patient, they have some consultants. So you have to just try to understand the business, define the entities, define the classes, define the relationship between these two, what are the generalization and specialization type of things, and then create a graph. One of the nice things about this course, again, some courses that you will learn after a semester, sometimes they are just like more conceptual stuff. They're just learning something, but it's not even though they are giving you tools, but some courses, the tools that you are learning is feasible. So by end of the semester, when you are able to create a database, technically you have a good tool to work with in the future. Right now, simple, people just by SQL and just by Excel, they are making 90, 95K as a starting job. Easy, as a data analyst role. My friends right now working exactly graduated from master program, international student for sure. If he had the chance to be here as a bachelor, probably he wouldn't pursue that master. Okay, but point is, he got the job now. He's working fully remotely, and he just had his own a newborn baby. So the wife has to work out of home. He's taking care of the baby at the same time doing a data analysis. So this is a type of course that again, at the end of the day, at the end of the semester, you will have some useful tool that you can claim that, hey, I can create a database, I can run a database. For sure, whatever you're gonna learn after in the job time, it's more valuable and definitely you will learn more later. But that's the type of course that I also enjoy teaching because again, at the end of the day, gives you a right tool in order to gain some benefit. Let me stop recording. Any questions?